Hello, good morning, everyone. Good afternoon for the other part of the world. Otherwise, it's good morning for a lot of people in Australia, and I think it's good afternoon for New Zealand. So yeah, I would like to welcome you into the call, the webinar. So the webinar is primarily about backup and restore strategies, and we are trying to evaluate the impact of backup in restore and disaster recovery solutions on a small and medium business perspective, because we have seen that only about 21 to 25% of SMEs are using an effective backup in DR plans. So it's not just that we're talking about in a broader scale. We are covering all about the disaster recovery options and much beyond a SME scale as well. But there's a good connect here that we can relate to the SME sector. And just to introduce the people on the panel today, so we've got Grant Young, so he heads sales efforts from New Zealand, Auckland, and we got Selvam Murthy, he's part of operations and sales support from New Zealand, Auckland, and we've got Nav, who's joined from Sydney, and Rakesh from Adelaide, part of the technical team. And Susan Dodd, she is joining from New South Wales. She's part of the sales effort team from Australia, and I am Ablash, part of the operations and sales support in Australia. And just to give a brief introduction about who we are and what's the agenda for today's webinar. That's where we are here for. So when we talk about us, that's ERL, it's Evolve, Innovate, and Lead. So we have started off, we have evolved from a conventional IT services provider to a contemporary IT services provider. We have started off, as you can see here, in 2010 from Microsoft, Cisco, and Avaya platforms. We started providing the professional and managed services within the conventional IT space, and we enhanced our skill sets in the D cores to unified comms, routing, switching, storage, and other cloud platforms. So in the D cores, we have gained customers of different magnitude, as we see here. Some of them are the Fortune 500 within the Fortune 500 list, and some of them are some of the super majors within oil and gas industries in APAC. So currently we are headquartered in Adelaide with offices all across Australia, New Zealand, and some part of Asia Pacific, such as Hong Kong, Singapore, India, and Malaysia, with over 200 plus staff. So when we say a modern day IT services provider, so along with all those conventional services, we now provide services and solutions around AI and blockchain technologies as well. And the agenda for today's call is, as you see here, so we're going to put it back to the technical team and the business consulting team. They would take us through the agendas as we see here on why to protect data and the concepts of behind modernizing the backup using the cloud, and some of the common backup models that we see out here. As I said before, we are trying to see the importance, or we are trying to put the importance of backup and disaster recovery plans within small and medium businesses, and also the disaster recovery approaches. And we would be glad to take questions and answers towards the end from, so the audience can type in questions, and so we can see when you put in a question here, and once the questions are in here, we can pull that up, and we can read it out for you, and so the panelists can hear them out and answer it right away. So feel free to ask questions as much as you want regarding the solutions and services that we provide here. and we'd be glad to take it further from there. All right, over to you, Rakesh.
Thank you so much, Avilash. Hey, people, this is Rakesh with Yale Global. I'm the IT business consultant on, working and helping our customers on emerging tech and the existing IT infra. So, as Avilash said, we are covering, uh, the disaster recovery approaches, for SMEs and the enterprises today. And the agenda was clear: why we protect data, modernizing backup using cloud, and common backup models, and the approaches on DR. So we'll go to a place where why do we backup data? The simple answer would be for any organization to be very, they want to be very safe and very secure. When they heard this word, why do they need to backup data? That is what. And when they say safe and secure, that goes to the next question: how safe you want to be and how secure you want to be. It depends on how much data they want to save, or how much data loss they are minimizing, using their backup strategies. So how much data you're protecting. Some people might be backing up the data every 4 hours, every one day, so they can afford to lose 4 hours of data or one day of data. Or some people might be doing a very real-time backup, so every minute they'll be doing the backup. They have a very minimized data loss. So that goes to another topic, which we say it is an RPO, which is recovery point objective of their current setup. This is why we do backup the data to minimize the data loss. So we saw how do we minimize the data loss, and we also need to cover when in the case of a disaster or an event, how short time we have to recover from the disaster and come back to the normal businesses as usual. So we call it as RTO, recovery time objective, how fast you can get back to your business using the backup strategies. So when we say, how much we can minimize the data loss, and how much, how much time we can minimize to recover from a disaster, it is associated with the cost. Any backup strategies associated with the cost. We have a lot of applications running inside the company. We can back up all the data of the application and have it in a separate place. In the event of a disaster, we can certainly recover from the disaster, but it is associated with the cost. And nowadays, companies, organizations started working out what is the priority data and what is not a priority data. So just to balance, the liability with the cost, where, when you can prioritize your types of data and have a particular backup strategy for that particular data, we can assure we can have a balance between the liability and the cost. This is why we do a backup strategy in the first place. So basically, as EL Global, whenever we are approached by a customer, most predominantly into the small and medium businesses, we have four phases of starting off with any requirements. Where first we identify the application to protect. Next, we do an analysis on the business impact. If in the terms of in the times of disaster, what can be the business impact, and how much we. This is the place where we jot on all the details and create a business impact analysis. And we define RPO and RTO based on the business impact analysis, which is basically recovery point and recovery time objectives. And we also have a financial requirements that goes into this particular third phase. And also we have a compliance consideration. Some organization might be having compliances to store data 100 miles from their offices. Some might be having compliances on security, where the data resides. So this is the four phase, we take to work with any requirement or start with any requirements. So there are some initial questions to answer, what we have covered so far. Uh, what are all the questions we answer from our customers? How important are the application to their businesses? What is the associated recovery point and time for this application? Where, how are we storing the data? And where are we storing the data? And how are we restoring the application? So these are all the basic questions we will be addressing going forward. So when we say, backup and recovery, there is always a traditional and there is always a modern way. So the traditional way being, we have our applications running in our environment, and our media servers helps backing up the data from the application servers and put it in a tape infra or a local drive. And we try to use some third-party services to create, a data bunker or archiving facility. Um, this is how our traditional backup environment works, whether in terms of uh, regardless of the sector, regardless of the size of the company. This is how the traditional backup environment was working so far before the cloud. um, yeah. So when I say the traditional backup approaches, and how do we have benefits from cloud backup strategies. What we leverage existing investment in infrastructure. We do not add up any more extra investment on the new infra, as in the cost for the hardware or licenses or anything, because cloud acts as an extended arm of your existing infra, and you can leverage the investment in the infrastructure, existing infrastructure. And the next being, the cloud is very cost effective, and you can do pay as you go. No upfront capital investment is required when it comes to the cloud. These are all the benefits of having a cloud backup strategies. And we can definitely eliminate the physical tape backup and administration of those tape infrastructure, because I think you obviously know, there is a significant amount of effort that needs to be put in to manage the backups and administer them. There is a cost associated with that as well, in terms of procuring the hardwares, in terms of managing the hardwares, and during the term of time of recovery, there is a huge amount of effort that is going in. And when we say cloud backup strategy, the major thing is like, we can have insights of our data. We can put in analytics to our data. We can have there are a lot of options we have in the cloud that we can put into our cloud backup strategy. There are a lot of artificial intelligence based appliances and machine learning capabilities of the cloud can be used for our cloud backups as well. These are all the immediate cloud backup benefits. There are a lot of other benefits as well. So we are an integral partner of AWS in this region, Australia and New Zealand, and and we believe AWS is the backup services of AWS, which is predominantly S3 and S3 Glacier, which is designed for 11 nines of durability, which is say you have 10 million of data, and the chance of losing one piece of data is for 10,000 years. Out of 10,000 years, there's a chance of losing one piece of data because of the structure of the data center, which AWS extend to their customer. Basically, there are 11 regions in AWS and 3 announced regions, and every region has multiple cluster of data centers named as availability zones. which has a redundant power networking connectivity, and they are housed in a very discrete and separate facilities. So this is to ensure where our data sits and how secure the data is, and how do we use the cloud for our backup and disaster recovery strategies. As I said, AWS comes up with a lot of regions, and cross-region replication is also possible. And in terms of in certain organizations have a compliance to store data 100 miles apart, and they want to have a specific latency requirements and a security requirements. So these can be accomplished using DR on cloud. So we can have one site at Sydney, and we can have our replicated site sitting in Asia Pac, somewhere in Asia Pac. Might be in Mumbai, might be in Singapore, say to make sure all the availability zones within Sydney is protected. Also, the DR site might be in somewhere in Asia Pac. It is also protected by its availability zones. When I say backup, there are patterns to each and every backup. So we'll look for all the backup patterns now. I would also like to introduce Nav. He's our technical architect, uh, working out of from Sydney. So we'll go with the backup strategy, and when and where we can have our assistance from Nav as well. So there are certain patterns to backup. The first one being the file gateway. It's a very simple, appliance where we have our file gateway set it up in our on-prem, and we back up the data and facilitate that data to go into the Amazon's S3 bucket, which is a simple storage service. And the benefit of having a file gateway is, it can be used to back up a data and transfer to the cloud system, as well as that file gateway also helps us to handle the cache of the backup, which in AWS it is up to 32 terabytes. So whenever something is wrong, we can locally recover the data from the cache of the file gateway. So there are a lot of use cases. One, backup on-premises data to the cloud. Number two being, hybrid cloud workflows, low latency on-premises access to cloud storage because of the cache handling. And number four being, content distribution and collaboration through cloud. Next one is the tape gateway, which is very similar to the file gateway, but except, rather than using the straight S3 services of Amazon, we use virtual tape libraries services of Amazon to just back up whatever data from the on-premises and store it as a virtual tape drive. And it can also be archived into the S3 Glacier for the later use when we have any need for any particular tape modules, which is stored as a virtual tape. In this case, it can be recovered and it can be used. I would like to have Navneet to take up with the volume gateway. Hey, Nav.
Hey Rakesh, sure. Hello all. So, yep. So AWS, as Rakesh was explaining earlier, AWS does offers different ways, different types of storages for backups, right? One of them being a file gateway. One of them is your virtual tape libraries. The other one, volume gateways, and then the snapshots. So for the volume gateways, I mean, like how you map your file storages to your on-prem, take a backup of your files, store it in the file storage, which will in turn sync it back to AWS S3 storage, right? The same way, instead of providing shares, AWS gives you an option to take the services from AWS and mount them as iSCSI disks on-prem. So from the on-premises perspective, you will see a disk mounted where you can dump your data, and then that in turn gets replicated or synced back to AWS, which is available for restore in the cloud directly. Right? That's how the volume gateway of backup works. And Rakesh, do you want to check up the EVA snapshot?
Yeah, Nav, you continue. Yeah.
All right. So, all right. The first three types of backups that we saw are for on-premises. So the file storage, the VTL, or the disk storage. So those are for how you back up your on-prem resources to AWS. The last option, the last strategy is Amazon EVA Snapshots, which is for Amazon workloads itself. Let's say we have multiple virtual machines running in different regions in different availability zones within AWS, right? And if I have to protect it, we'll be enabling the EVA snapshots for those virtual machines or EC2 instances. So in AWS, we cannot back up your EC2 as such. So these snapshots are at the disk level. So we'll be enabling your snapshots at the disk level. And then when you want to restore, you'll be restoring the disk, and we will create a VM out of it. Or if I have to back up the entire virtual machine, we'll be converting them to an AMI image. So there are ways we can protect your EC2 instances, one at the disk level, or you convert them to an AMI image, is what AWS calls, which exports your virtual machine and have it ready for instant creation of new machines, right? And these backups, they can be automated. There's a functionality called AWS Backups, which will help you schedule these backup jobs, and it also helps you get notification and reports out of it, right? The AWS Backups is a new feature which was released pretty recently, last year. Before that, we used to do that with CloudFormation templates. There are schedulers which will allow us to schedule it, but AWS has recently made the lives of many IT administrators easy with AWS Backups, right?
Fantastic.
Okay, so all right, for the EFS, like how we protect the EC2 instances or the virtual machines in AWS, how will we be protecting the applications hosted within the EC2 instances? Right, I have an EC2 instance, I have databases hosted, I have logs stored, I have flat files stored. So backing up a disk will give me a point in time recovery, which is nothing but a snapshot, right? But it doesn't guarantee data consistency or file integrity. So if I have a database or an application running on top of these EC2 instances, and if we want to protect that, so I'll be taking an elastic file system feature from AWS, mount it in these EC2 instances, do a proper consistent backup to these EFS file systems, and then store it in the S3 at the backend for a longer retention, right? So that's another way you can protect your applications.
So thank you so much, Nav, for explaining things which happens inside AWS. So I'll take it up with the solutions we provide to our
Sure.
customers from EL Global. Hey, people. I would like to explain about the solution strategies we extend to our customers in terms of disaster recovery and backup strategies. So the first one being the backup from on-premises to the AWS. So here you can see there are three stages. You can see the corporate data center, which is our on-premises, and the connection media and the AWS cloud system. And we also have listed some of our technology partners. So this is how it works. So we have our existing setup in our on-premises, and we have facilitated a backup master server there, and we also have a backup software. So we can have the backup target option using any of these services, which is a local S3 backup target, Amazon Storage Gateway, or a VTL, and through the Amazon Direct Connect or VPN or internet, it can be pushed through the AWS cloud or any cloud, and predominantly to any region, to any services, with predominantly the services being S3 or S3 Glacier. So how it works, the corporate data gets to the backup server, and we have a target option, and we connect through a media, and we just push it to the cloud. This is a very simple setup for a backup from on-premises to cloud, a single site to the cloud strategy. And we also work with multiple sites to the cloud strategies. So where organization might be having a lot of branch offices, and they want to have a backup strategy on cloud, and they want to have a very cost-effective and efficient backup strategy. So this is what we do. We have this corporate data center being the headquarters. They have the master backup server up and running, and we do not recommend to have any backup server on any of the branch offices. Than they are connected directly to the branch offices are connected directly to the backup server within an AWS cloud, and in the event of a failure or in an event of a disaster, the corporate data center pulls the data, or it is a federated setup where the backup server sits in the AWS. Works in conjunction to the backup server in the corporate data center, which is an on-prem. And in the event of a disaster, they both communicate, and the backup master server from the on-prem access the data from the the backup server in the Amazon cloud. So this has the same functionality, same process. You have a master server setup in the on-prem, and we have the target options through multiple services, and we connect it to the cloud via AWS Direct Connect, VPN gateway, or internet. And we have our VPC setup there, where we have the a cloud backup server, a federated cloud backup server with S3 and S3 Glacier services as well to handle our backups data. This is the multi-site to AWS backup strategy. And the next one, is a SAS backup model, which is a very easy to use a backup strategy from on-prem to the AWS, where we do not need to configure anything on the AWS cloud. We have our client sitting in our corporate data center. We have this our partner backup software running on the corporate data center, and the software has a pointers that can directly spin resources on AWS cloud and target the backups to the cloud directly by configuring automatically. This is how a SAS backup model works. It's a very simple services. It does not require any additional cost. Everything is within the software's capacity. Yeah. So there are benefits to it. One, the utility pricing and no extra infrastructure required for this model, and it can scale up to a certain levels on demand. I would like to have Navneet here to explain on EC2 backing up Amazon EC2 instances with on-premises hosted controls.
All right, sure, Rakesh. So, right, this is a typical scenario in the enterprise segment in the recent days, right? So most of the companies are on a hybrid setup where they have their on-prem data centers. They also have workloads running on different public clouds. For instance, they have a data center on-prem, and then they have tenants set up in Azure, and then they have different accounts set up in AWS, and they'll be running different applications, different workloads in these different data centers and the clouds, right? So backing up portability of your systems across these systems across these data centers is very important for the application availability. Let's say you have a development environment on-prem, you're done with the development, you want to move that to cloud, or you're hosting an application on-prem data center, you want to set up a failover copy in the cloud. So that's when you put a backup server on-prem, you protect those on-prem virtual machines with the backup server, and then you keep another backup server in the cloud, and you keep the backups replicated, and then you can restore that as a virtual machine directly. That's one way of doing it. On the other end, let's say you have many virtual machines running in cloud, and the native backup solutions that's offered by Azure or AWS is not giving us what we need. Like, I need a file level recovery, or I need a database level recovery, or I need a full server recovery. We usually don't get from the native backup tools from these cloud providers. So we still go for tools like Commvault, Veritas, right? They provide those options. So in that case, we put a back cloud, we back up the cloud virtual machines, and we restore them to on-prem or to cloud. Or let's say I back up an AWS instance and I restore it to Azure. So these tools can do that for us, and that's how we control the backup of the cloud from your on-premises.
Fantastic. So I think now this is within the backup within the Amazon environment.
Yeah, it just just full cloud, right? So you have the workloads running in in the cloud. You have the backup servers in cloud. Instead of controlling that from on-prem, you control that directly from cloud. It's the cloud to cloud backup, right? You put the backup server in cloud, you back up the EC2 instances, and you can recover them, and you can take full advantage of the backup tool functionalities. So GRT, or granular recovery, is one of the features which is predominantly used in everyday backup recovery scenarios, right? There are many other features that we need. There is indexing, right? There's as I said, a database level consistent backups. There is a file system level backup. There are shares that you can provide. There are near zero replications that you can do with these backup tools. All that are possible, and that's completely for cloud.
Fantastic. So thank you so much, Nav. So we'll straight away jump into the disaster recovery and the use cases and the architectures of the disaster recovery we support. So every business, people think, only large businesses needs disaster recovery and the data protection. Not like that. Every business requires data protection. There are a lot of disasters, that are hitting the businesses, and the businesses continuously losing customers because of in the event of a disaster. Natural disasters, it can be, infrastructure availability and access. It might be a huge power outage. It might be someone acting rogue and compromising our internal systems. So we need to have, recover from the event and get back to the business as normal. That is why we strongly recommend have a data protection strategy in place using TRs. International data company estimates that up to half of all the organizations across the globe doesn't have a disaster recovery strategy, strong recovery strategy in place. And even on the second half, they have only 48.4% of their application covered by a DR plan. So ultimately, 51.6% of the entire organization across the globe doesn't have a disaster recovery plan, and they gave this fact as an alarming fact of the year 2019. So the theme of this webinar is to walk you through the cloud disaster recovery architectures, principles, and benefits. So this is the benefit of having a cloud disaster recovery. We'll see what is the how traditional disaster recovery works and how it works in the cloud. For traditional disaster recovery, you need to have an independent site set it up with a massive upfront investment in terms of hardware and in terms of licenses and in terms of the ongoing maintenance cost. Uh, and obviously, the data growth is on daily basis, and that amounts to the more hardware and more operational cost. And when we say DR, every periodically there is a process called DR drill where we test the DR whether it is working really fine. And in terms of with respect to traditional disaster recovery, it is very, very hard to test the DR without business disruption. And the overhead of the management and infrastructure, it is very high. And like the traditional data center, the traditional disaster DR site is also vulnerable to cybersecurity threats. While you have your DR in the cloud, there are a lot of benefits. There is no upfront hardware investment or license investment. You only have to pay for what you have using right now on hourly basis, and the management cost is 90% reduced, and you can avail for more automation on the DR. We can do the testing, and it is easy. We can repeat the testing multiple times, and it doesn't disrupt our business process at any moment. And we can have the systems up and running, the recovery up and running in even in minutes, not hours, not days. We can set it up even in minutes. We can have the recovery even in minutes. So there are 4 levels of backup and DR support. Based on the complexity and time we can offer our customers. One being the backup and restore, which is the low level one. It's very cost effective. The advantage of having a backup and restore strategy is very, very cost effective. The downside of it is the recovery point objective. The data loss might be somewhat higher. And the solution we use for the backup and restore is basically Amazon S3 Simple Storage Services and Storage Gateway. This can be used on low priority use cases where we might have some non-business critical application or data that we can use it as a part of a backup and restore strategy. And there is a pilot light strategy, which is better than backup and restore, and it is also very complex when it comes to the designing one in the real time. It costs more than backup and restore, but it is very cost effective when it comes to the functionality. We can scale AWS resources in response to a DR event at any given point of time, and the recovery is in some tens of minutes, not hours. When it comes to backup and restores, it takes several hours to get it restored, but in terms of pilot light, it takes tens of minutes. We can set up the pilot light with a good RPO and RTO based on the business requirements. The next one being the warm standby using AWS, which is basically active and passive setup. Here, the recovery can happen even in several minutes based on the business requirements, but it is the cost advantage is slightly lower than pilot light. It is quite expensive. And coming back to basically it fits into several areas where they require low minimize data loss and speedy recovery. And there is the next one is hot standby with multi-site. We call it as active setup. So it is a replicated real-time replication of your current site to another location and switch back between the sites. So the the return the recovery point is very low, and the recovery time is also very low, and it can be real time as well because of the active setup in the hot standby with multi-site setup. So I'll give on to Navneet to run through the architectures we deal with in terms of with respect to pilot light, warm standby, and hot standby.
All right, sure, Rakesh. Thanks for that. Thanks for the briefing. So, all right. So, as Rakesh was explaining, there are 4 different ways we can achieve the recovery. The first way being a simple restore from the backup that we take. That's the most cost effective. So we don't need a parallel setup. We don't need additional infrastructure. We just have to make a copy of the existing data, maintain a point in time recovery in a dedicated storage, and recover it whenever it's needed. The only downside to it is the RTO. So RTO is the time that it takes to recover the system, right? So, but it all depends on the business criticality. If maintaining a point in time recovery more critical than restoring the system as soon as possible, backup and restore is the best strategy, right? Or let's say in today's world, most of the SMB customers, most of our small and medium based customers prefer to go for a pilot light recovery. What it does, so let's say I have I have a small environment where I have 50 to 100 systems hosting few different applications. I have it in a small server room or a hosted data center where I host all these VMs on top of a few physical hosts. And if I have to set up a parallel infrastructure for the DR purpose, it's going to cost me more than 2 times to set up the second site, right? I mean, you've got the infrastructure, you've got the power, you've got the circuit that it needs, the bandwidth that it needs. It's going to cost more than double to set up the DR. So what we offer in cloud is you don't need an infrastructure for having a DR. So there's a concept there's a tool called Endure within the AWS, which allows our customers to replicate their data to cloud. So it's a block level replication. We will configure it in your environment. You don't need absolutely no infrastructure, physical infrastructure. All we have to do is set up some cloud. We have to make some configurations in the cloud. We'll install the agents on your machines on-prem. It can be Windows, it can be Linux, it can be any server. It can be a physical server too. So we will start replicating your data from on-prem to cloud, and it'll be a block-to-block replication. It's not an OS, it's not an operating system, or it's not an application replication. It's a block level replication. And that'll be stored in cloud, right? When something goes wrong in on-prem, you will just have to go to cloud and just power it on, and your DR system is ready. So without procuring any additional infrastructure, just by replicating it to the cloud, keeping it ready for the recovery, we are avoiding the entire cost, but also availing the DR functionality. That's the pilot, but this requires some manual intervention. So if something goes down on-prem, you still need to have a good monitoring system, alerting system, and notification systems. So your administrators should go to on-prem, make those changes in cloud to make that, make the DR system come up You may have to make some DNS changes, IP changes. So that's why it's not the most preferable. It's definitely the cost-effective way of achieving the disaster recovery, right? So we'll move on to the next one, which is a warm standby. So warm standby is active passive setup, we would say. So there are companies and applications which cannot afford a longer downtime, right? So you have a site A, you have multiple sites, and you have server rooms and data centers in each site. So what company typically does? So they have a fully functioning site where they where they have hosted their servers, all the applications, everything running. It receives the request, it serves the request, and something goes wrong. There is always a second site readily available with all the data replicated over continuously. So there are tools like Zerto and other tools which will help you achieve this. So you can keep two different sites continuously replicated and up to date, and you can either choose to have the site A or site B based on your application and the recovery time. So that's the warm standby setup or active passive setup. Something goes wrong, site A goes wrong, you can start using site B, right? And it'll just be a DNS change. So, active passive setup, most of the manual efforts will be eliminated by the pre-configurations that we do. So we don't have to do a lot of configurations like how we do in pilot setup. In active passive, everything except the DNS changes would have been pre-configured. So it does cost you the infrastructure, but it reduces the amount of time to recover your business, right? So the next item is a hot site, which is what we call an active setup, right? So most of the financial institutions or the pharmaceutical institution, manufacturing industries, where they cannot afford to lose any transactions, any logs, they always have an active setup with live replications. It's not even a log shipping with few minutes delay. These are live replications between multiple sites. So this is achieved typically. It's a combination of high availability and a DR. So a good example would be if you are familiar with the Microsoft tools, Exchange uses database availability groups. SQL uses always on feature. So what they do at the app level itself, or they are distributed to multiple sites where they are constantly replicated within and kept updated. And all of these instances can receive requests at the same time. Unlike the previous setup in the warm standby, either site A can receive the request. Either site A can be in production or site B can be in production. Site A and B cannot be productive at the same time. That's how it's set up. But in the active, it is expensive, right? It is the most expensive way of achieving the DR of all the methods, but it's definitely the most effective way to. It has the least RTO, so almost zero. Your application continues to function as if nothing has happened. So because your application would have been distributed to multiple sites, you may be having a data center on-prem, we may be replicating a copy to another site in a different region while we have another fully functioning setup in cloud. So the site A goes down, there's no difference. Users or the application wouldn't see any difference. Just the administrators will get a notification that this site is down, but the application will continue to function as if nothing has happened, right? That's the active setup. And this is a fully automated end-to-end recovery. We don't have to make any changes. For instance, an application running in multiple regions. So there are concepts like the traffic managers, which we put in place Based on the origination of requests, the traffic will be routed to the specific region. So if one of the nodes is not available, those appliances, those systems that we put in place will take a call automatically and route the traffic to the available nodes. So it's a completely end-to-end automated solution. The active DR solutions are, right? So Rakesh, can we move on next one? Yeah. Rakesh, you want to cover this one?
You take it up, Nav.
All right. Okay. All right. So the Cloud Endure, as I was explaining earlier, Cloud Endure is an AWS feature, and it helps AWS to replicate the block level data from your on-premises server to cloud. So how it works, it's typically nothing but an agent which gets deployed in your server. So we put an agent, we do a discovery, we understand how your on-premise setup, we configure the AWS similarly, and then we start replicating the data. And once the data is replicated, we do a small test. So we can, instead of before going to production or before cutting it over to the production or failing it over, we can do a test. Is my data intact? Am I able to log in? Do I see all the necessary drives I should be seeing? Do I see all the services that are needed? So I can do a test and then I can cut over and then bring it to production right away, right? So that's what Cloud Endure does in AWS. It helps, or it actually replicates the data from your server to a staging environment in AWS, right? So this is a typical use case for lightweight staging, right? The source location is an on-prem. So when we say boot and data, it's just a Windows server which has two disks. Boot disk is an operating system disk. The data drive is where you could be your a database drive, could be a logs drive. So we have a Windows server, we have an Oracle, we have Red Hat, and the Cloud Endure agent will be installed on all of them. And when we are done with the discovery, a continuous data replication will be initiated from the on-prem to cloud. So any change that happens at the source location at a set frequency, the changed blocks will be replicated to AWS. So someone might have a question, how does Cloud Endure knows if something has changed, right? So there's something called change block tracking within the operating system. So whenever anything is changed, a journal is maintained by the agent, so it knows exactly what is being changed and it will replicate only those changes. So that's how it replicates data. And when you want to fail over, when you want to cut over from the target location, which is the AWS, we can do a testing and failover without impacting anything on-prem. So let's say we've been syncing it continuously, and there is a hardware failure, and you don't have a maintenance contract, or it's going to take a day or two to receive the disk. The RAID is full. We just have to power on the host, power off the host, and power it on in cloud. That's all we have to do. Or even if the entire site is down or the ISP link is down, we just have to come to the AWS, power on the synced systems, and they'll come to production right away, right?
So Nav, I think we have got some question from our audience. So for us to address, I think we are getting some questions.
All right.
So we'll jump directly to the questions now. So Abhilash, can you help us with the questions?
Sure. All right. Susan, either you got questions?
Yeah,
Anyone
yeah.
who's got questions can shoot up and
Yeah,
go
definitely.
ahead.
I've got a lot of topics to talk about. It depends how much time we have. But look, as I'm listening, and thank you, Rakesh and Nav, good job there. You've presented a lot of really useful information. And it actually reminded me of a lot of companies that I've worked with. They've had disaster recovery solutions that weren't in the cloud. And one of the biggest challenges they had was they couldn't test their disaster recovery plans. And so often they found their disaster recovery plans weren't adequate enough. But it was good. I saw that you pointed out one of the really big benefits of having disaster recovery in the cloud is that you can thoroughly test it and you can change things and retest it. And I think that's a huge benefit, having disaster recovery in the cloud, which then leads to a topic I'd like to get you guys' opinion on is when should a company consider approaching us about their backup and disaster recovery plans? Because as I said, a lot of companies think they have something adequate in place, but then they have a major outage and disaster and realize that they weren't really properly prepared at all. So what do you guys think about that?
Um, Susan, that's a nice question. So I'll try to put everything one by one. The first thing we were talking about the DR testing. So there is a process called DR drill. Whenever we have DR in place, there is a process to have a periodical drill to test the DR. Since it might cause some business interruption, people are reluctant to do very frequent testing to make sure the DR is working well. But cloud solves the problem now. It does not, intrude or interrupt our daily business hours. The DR drill can happen on the cloud separately, and it works really well. That is number one. And the next question, I understand, when should one consider disaster recovery? That's a very tricky question. So whenever we feel the data we have in our company is very important. So now it is a digital age, and the very most important thing is not money, it is data now. So when we think the data is very important, we definitely should think about having a disaster recovery or a backup plan, backup and restore plan.
Yeah, I
That's what I
like that
believe.
answer. No, I like that answer a lot. Thank you. And then you've presented a lot of choices here. How does one go about understanding which choice is relevant? What is there a process or criteria? How do you approach it?
So whenever we start a conversation on DR with some of our customers, we don't jump directly into a conclusion, telling them or recommending them this is what you need. So we sit with our customers and understand what they're trying to accomplish out of a DR. We try to read the data patterns, what kind of data they have, how much of the data is priority data, how much is non-priority data, or the less prior data. So we create a business case, business impact analysis case with them, and we try to negotiate with their internal teams on the impacts of having various DR, uh, uh, s- you know, architectures, and what is the cost implication of having each and every DR setups. And whatever we propose to our customers is subjected for financial approvals, so we have to take those things into account, and we work out a plan. And many companies have some compliances in place, so we have to work a DR plan based on the compliances. We have to do some adjustments on the plan. Some might need a DR site, set it up 50 miles or 100 miles away from their primary site. Some might need some HIPAA compliance on their DR site as well. Some might be having PCI DSS uh, uh, credentials, and they want to extend that to the DR site as well. So we need to sit with our customers, understand the type of data we are dealing with, and suggest them with the right solution. We don't just directly jump on to conclusions saying We want, personally, I would like everyone to have a very active DR setup, but that is not the case with everyone. It is very expensive. So we sit with the
Yeah.
customers, understand, and work out the solution.
Oh, that's good. Yeah. And so I'm assuming then it's clear that the DR plan is really critical in an organization. And most
Exactly.
organizations think that their DR plans are pretty good. Often they are not. So are you able to look at their current DR plans and then work with them improving the plans?
We also do that part of our consulting services. We work with all of our customers, and when it comes to an assessment, DR also comes into the framework. So we also help them assess their existing DR, give out our recommendations. So if they are having a very good setup, we tell them, we encourage them that to continue with the setup. If we come up with any suggestions or recommendations, we don't hesitate to pass it on to them.
Of course, good. And then with all those options, let's say you help a customer go down a particular path.
Mhm.
Is it likely that they're going to need to bring extra staff on board in order to support those options?
When it comes to a traditional DR, yes, there is a human resource required. But when it comes to cloud DR, 90% chances you do not require an additional resources. Yeah.
Okay, good. And then I assume there are good daily monitoring tools where the managers or the IT staff can monitor what's happening to data. Are there any issues with data or backup or recovery issues, things like that? So I assume that there's a lot of capability to customize dashboards and monitoring tools.
Uh, yeah. Uh, we have a lot of management modules available to monitor our cloud infrastructure, regardless of whether it is a DR or not. We can obviously monitor our cloud infrastructure and what happens inside cloud. And I would also like to cite what Nav was talking about, change logs. I would like to pull Nav in for this conversation.
Yeah. So for the on the monitoring aspects, I mean, we do collect logs, and there are visualization tools like the Power BI, Grafana, where we take advantage of the visualization and we provide custom dashboards, which actually scores the customer's environment against the standards that we put in place. There are best practices that we follow, which will score the environment. It will tell us if we are compliant on the backups. Let's say your backup SLA or this backup success percentage is 94, or average backup percentage, success percentage is above 90 for 1 month, it's definitely not in line with the best practices, right? So we do maintain dashboards. We provide that to our customers. The same goes for the DR. And just to add to what Rakesh was explaining earlier, we do encourage customers to do a frequent DR drill. If that is expensive, at least a random restore test at least once in a quarter. So we always ask the customers to pick a server, randomly delete something, try to recover that from your backups. That's one of the best ways to validate that the data that you backed up is good enough for the restore, right? That's the first step for the DR.
Right. Okay, guys, that was nice. Thank you. And then, look, I've got just a couple of other topics. In Australia, the government has Australia cloud only policy, meaning, and I don't think it's changed recently, that the data centers have to be in Australia. So I imagine there are clients you deal with, such as Australia, where we have to consider where the data is actually going to be backed up. Do you find that that's an issue? Is that a sort of a challenge to deal with?
Um, to address this question, I would say if AWS is there in Australia, their location is Sydney, and they have 3 availability zone within the data center range. So the data resides inside Australia in this case when the customer chooses Customer always have the options to choose where their data wants to reside. So they can choose Sydney in this case, Australia, Sydney in this case. If they want to have their data inside the country. With respect to the government data, they obviously can subscribe to GovCloud of AWS or Azure. They can subscribe to that facility feature where they can host government data within the country and in a more secure way.
Okay, good,
There's an
thanks. And
option
then
to do
look,
that.
okay, great. And look, just the last topic I've got is really about pricing. And I know we can't talk directly about pricing, but are the options are their price points very different for the different options? So is one option maybe 100 times more in cost than another option? Can you give us a possible feel for the pricing differential?
When we were discussing about the spectrum of backup and DR setups, the simple backup restore being the very simple one, which is very cost effective, which costs nothing compared to any other DR setups. So this is what I would suggest. I would recommend about the cost. It cannot be. I cannot just like that, spell out a cost, an
No, of
approximate
course
cost,
not.
because
No.
there are a lot of factors into it when it comes to cloud. The amount of data, the amount of servers they have, amount of infrastructure they have already in the on-prem, and what kind of setup they want. The cost varies accordingly, but it's going to be very cost effective than having a traditional DR setup on premises.
Right. Okay, good. Thanks for that. Well, look, I'll hand back to Abhilash if you've got topics and questions that you want to proceed with.
Yeah, thank you, Susan. Yeah, we've got a question from the audience again. That's one is hot backup seems like a great DR solution, but what happens in the case of a virus or data corruption or accidental deletion? These would all be live replicated. How would you cater for these scenarios? Do you want me to repeat that?
No, all right. I'll take that up, Lash. All right. I believe the question was directed toward active DR setup. Right. So backing up the environment and having a highly available solution are two different items. And I completely agree with the question here. So if my site A is infected with the malware, and if I'm doing a live replication, the other side easily gets infected, right? So that's why we always take a point in time backup. That's why we don't leave the environment just with a highly available solution or a cluster solution. So we take a backup every day. It's usually a Monday to Thursday incremental or Friday full, which will take the incrementals of your environment, and it will allow you to go to a specific point in time in case of such events, right? And adding to that, tools like Commvault, Veritas can scan your backup data and tell you if there are any malwares. So the last time when there was a WannaCry instance, Commvault was the first tool which identified the infected systems in the environment. It was not even antivirus. So backups are that important, and it can scan and can protect you from such instances. Hope I answered your question.
Yeah, I guess so. Thank you very much for that. Yeah, I think that's it from the audience. So if we don't have many questions much, I think probably we'll call the webinar off. So we've started off the series. We've got another, the next producer coming pretty soon. I think we shall announce that sometime early next week. So that's going to be about the continuation of the same subjects. I will have more details coming in our series session soon. All right, thank you very much. Thank you for your time today, all the panelists and all the attendees, and you have a great rest of the day ahead. Bye for now.
Okay, bye.
Thank you all. Thank you so much.
Good job, guys.
Thank you so much, Susan.